be able to complete the notes so that we can cover, because by next week we are working basically on ArcGIS Pro. Everything we'll be doing next week will be on ArcGIS Pro. But up to this week, our mission is to actually interrogate and expatiate on this database design. Where we stopped last time, we were talking about the entity relationship model. But when I review your course content, I find that I hope I'm not overburdening you with too much expo, extra, put extra, extra, extraneous materials. However, as I tell my students, I'm not going to set any question beyond what I've taught you. And what I've taught you, I expect you to work within that area and give us a good a good and give your exam now. What's my good afternoon? Daddy, good afternoon, sir. Daddy, I sir. Yeah, fine, sir. Daddy, mo sir. Fine, daddy. Actually, pick by more is more class or more class, more class or one. More class or one, sir. Not by class, I'm paying. More online class, more office. I'm not office. Daddy, my teacher, my paying. That's my paying. Okay, class, I'm very sorry for the interruption. So, as I was saying, I'm happy today because at least I have a note to show you. Now, today, for the remaining 45 minutes, we'll be looking at type of data models and data modeling in details. Now, data models, I know that you guys know about data. Data, at least you have come across you have come across buildings, land, information, you have come across coordinates, you have come across description, attribute table, properties of land, you have come across remote sensing, you have come across total station, you have come across theodolites, you have come across so many surveying equipment. You have even went outside the world, outside the four corner of the school for IT services, IT internship, where you have been exposed to some equipment that are in your school environment. You have even do a site work or site seeing. There we come to investor they go and see how an eco standard operates, what kind of data you gather using an eco standard. You have seen a lot. Really, you have seen a lot. You have seen a lot. But what does that tell us? All this you are seeing, presently you are seeing my screen. I hope you can see my screen.
We can see your screen, sir. We can see.
Good. Now, all this thing you are seeing, you can see my screen, you can hear my voice, you can taste my food, even though you have eaten my food before. You have not eaten my food, but you can taste my food, you can smell my food, even you can even touch my food. So that means that you have senses. I believe that nobody here is blind. Do you have a blind person in our class?
No, sir.
No, we don't have a blind person in our class. That means yes, we are human being. Now we are complete human being, we are complete surveyors. Surveyors complete in all senses. Now, all these things you are seeing, all these things you can sense, they are all data. Now, data, as well they are very fast. So in the academic line, we have to now science of models. What we call models, they are called assumptions. They are called more or less concepts by which we can differentiate different type of data. Some people differentiate geographic data from spatial data. There's some people you differentiate statistical data from biological biometric data. this and that and this and this and this. They are just trying to differentiate, describe data. That's why we have what we call data models. Now, there are two major data models that we are looking at. One is the high-level conceptual data models. Now, what do you mean by high-level conceptual data models? High-level conceptual data models are models or data types or data models that try to actually present data that we human being can understand. Like if I say you're a student, and as a student, you're a data to me. Being able to, I can understand you. Being a student, so you're a data. That means quick one. You are as a student, you have a course that you're doing, you have a school that you belong to, you have a course, the course submission that you're offering, you have a grade in a particular course, you have a lab that you have to do, you have an assignment that you have to do. So as a student, you're a data with so many properties. And as a student also, you also related to another person. Maybe as a student, you are related to a lecturer, you are related to a school authority, you are related to even your parents. So are we together?
We are together, sir.
Yes.
We are together.
I hope I'm making sense. Or am I too fast?
No, sir. No, sir. You are making sense, sir.
Okay. So now, when we are presenting data such a way that people can understand easily, that is relates to people's ways of life, like a society. We are presenting data in form of a society, and in society we have families that make up a society. In the society, we have government that controls the movement of people. We have government that regulates money being circulated or being used for buying and selling of goods and services. So definitely, in a human society, we know this thing exists. Now, when we have presented data in that kind of form, then we are using what you call an high-level conceptual data model. Now, example of just an high-level conceptual data model is the entity relation data model. I talked about entity relationship data model, where we have an entity. An entity has an attribute, and each entity relates to an entity class. Within an entity class, each entity relates to one another via relationship. So the same thing goes for a human being. As a child, being a data, I have some properties. I have a name. I have an height. I have a skin color. I have a an eye color. I have a nose. I have a kind of way I'm used to. I have a way of behaving. As a result, an entity class of my own. And as an entity class of my own, I also relate to another entity. Maybe my father. The relationship between a father and a son. A father give birth to a son. So definitely, I can relate to the data when the data model is being presented in such a way. We are referring to just a data model as a entity data model. So as a result, such a data model type is classified as an high-level conceptual data model, such that people can actually understand it because it's people's oriented data model data view in such a manner. People can actually relate to it better because they know that 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 is more or less referring to an object as a human being that has attributes, a human being that has relationship, and a human being that can stand on his own. So that is what we are trying to. That's when we are talking about. That's what we mean by an high-level conceptual data model. Now, secondly, let's go down to the second type, which is called the record-based logical data model. Now, record-based data model, like as the name implies, record-based is basically like keeping records. Is until you get to a record before you know that you're okay. Yeah, now this one, it has a row, it has a column, it has a table, it has a way where it links to. It has a location. That kind of database is called what do I call it? It's called record-based logical data model. Now, what do you mean by record-based data model? We can say a record-based data model presents concepts user can understand. Concepts, as you thank God that you know a table. You know a table. You know a keyboard. You know alphanumeric characters. You know alphanumeric characters. You know how the binary numbers, binary system. You know a directory. You know a folder. Thank God you know a folder. You know how a folder can be mapped. You can solve, you can save in a folder, can save in a folder, that is in a folder. Yes or no?
Yes, sir. Yes, sir.
You know
Yes,
a
sir.
computer network. Abi, you don't know a computer network.
We know computer network, sir.
You know what I mean by a cabinet, a file cabinet. You know what you call a file cabinet? Where you keep your files. We know that, Abi. How we keep our files.
No, sir. No,
Okay.
sir.
You don't know a file, a file cabinet.
Okay. No, sir.
You don't know a file cabinet.
No, sir, we don't know.
Okay, a file cabinet is a you have seen before. Maybe you don't know the name. I will show you an example of a file cabinet now. Where is it? Okay, let me go. Let me go and look for example of a file cabinet for you. So for those of you that don't know that, the name is a file cabinet. Can you see my screen?
No, sir. We can't see your screen, sir.
So can you see
But we
my screen
can
now?
see.
You can see it now.
Yes, we can
Yes,
see.
sir. Yes, sir.
This is a file cabinet in your boss office, in your lecturer's office. If you go to a lecture office, they all have something like this. Yes or no?
Yes, sir.
Yes, that's a file cabinet. That's where they keep files. It's called car cabinet. That's where you keep your documents. Your document. If you go to your HOD's office, you will see a file cabinet there. That's a must. A must are all office has a file cabinet. That's where you can even some have a cupboard where they keep records. So that's, yeah, for a chef that has a record. That's where they keep record. So what we're saying is that for a record based logical for a record based for a record based logical data model, it presents concept that we can understand how files are kept, how records are being stored. So in computer or in anywhere. So that method of keeping records, is that what we mean by a data model, record-based data model. Any record data model that uses any data model or any data model that uses a concept of record keeping or record-based system is called a record-based logical data model. So example of such a record-based data model is the relational data model. The relational model, where I thought that the relational model involve using tables. When you use tables and row, you say, okay, this table should be for student alone. In that student, we have names of the student, we have the course of the student, the grade of the student, the matric number of students. Such a table is called a relational data model. Now, also we have a network-based data model, where each entity or each record is linked to one another via a network system. We then have an hierarchical data model as an example. Now, looking at this one is an example of a, like I've said before, a relational database. It's an example of a relational data model. It's an example of a record-based logical data model that uses relations or tables to present data. The other one is a network model. The network model, data types, we have data records. Data are presented as record types. These record types are in limited types, meaning that if you say this is an item, that item has limitations. It cannot be used for another thing than what is being certified to use for. Now, record limited types of one to many. In this network model, we have one to many kind of relationship, and each relationship are called set types. Now, example of a network-based data model is the figure you are seeing. In this figure, you can see MEPs, and this MEPs goes to each departments, and department manage NEPs. And NEPs move to another sector we call items. In data items, we have entries. In this entry, we have orders. We also we have customers. So when we can have map a data that moves from one department to another department. Imagine in your school, we have faculties. In each faculties, we have departments. In each department, we have units. And this unit relates to another each unit relates to another unit within the school environment, such that we are having a system where, imagine as a student, after finishing your 5 years, before your end of your 5 years in school, all your data have been managed by the department. But part of this data have been sent to your DSA, that's your Dean of Student Affairs. Part of this is also been sent to the Senate for yearly consideration of results, even session consideration of results. Can see that you are forming a map. Aren't you not forming a map? Aren't you not forming a map? Hello, class. Am I talking to myself? Hello?
You're not talking to yourself, sir.
Hello? I'm not talking to myself.
We
I
can
asked
hear
a
you,
question.
sir. We can hear you, sir.
I'm
No,
asking
sir.
a question. Are they forming a map?
The area is 16,666.
I can't hear you.
660.
Hello?
No, sir. We are talking. I
Hello,
think
sir. We are here.
Please, when you can, because I have class by 2. You have to
Okay.
take it for 2.
Anyway,
Anything I want to
let me
do.
move further. So, in a format, in a kind of a flow chart, the network model present data as record types. Each record type having one to many kind of relationship as a set type. Now, moving forward, we have relational models. Oh, sorry, this is not relational models. This is hierarchical. This is called hierarchical data model. So, hierarchical data model represent data structure in a hierarchical tree structure. Meaning that
Hello, sir.
I can hear you.
Yes, sir. Sir, your screen is still showing cabinet. So
Is it showing what?
cabinet.
Ah, thank you. Hey, yeah. What about now?
It's showing well now, sir.
Okay. So we have the hierarchical model where data are represented in the form of an hierarchical tree structure, which each tree having where we have branch of hierarchical representing a number of related records. Imagine in the department we have EMPs, we have managers, we have items. The items are being organized into entries and offers. In offers now has hierarchy. We have offers by the customer and offers by the suppliers. So when we are presenting data in the form of hierarchical tree structure, then we are using what you call an hierarchical model that can be classified as a record-based relational model, a record-based data model. Now, before we close the class for type of data model, at least on this note, I can assure you, I can be assured that you know the two main categories of data models. Yes or no? Can I be assured of that?
Yes, sir.
So now, some key terms in data models that you have to familiarize yourself with. One is the hierarchical model, which we have said that more that another hierarchical model that are represented in what? In hierarchical tree structure. If you get the word instance, an instance is a record within a table. When we have a table of students and the word, the name, Faith Adeni comes up. That Faith Adeni comes up, that Faith Adeni is an instance in a table for students, of which Faith Adeni is a student. Now, we also have network models. We have said today, network models are type of models where data are like record type. Then we have relation. When you hear the word relation means another word for table. So when you hear the word relational models, are kind of models where tables are being used for presenting data. Then we have set types. Set types are limited type of one-to-one, one-to-many relationship. So now, get to the gentlemen of the press. You take your tissue paper. Hello, are you there? You have to take your tissue paper. Or you type somewhere and you submit within the WhatsApp group. You submit within the WhatsApp group where you answer this question. What is a data model? What is an entity, an attribute, and relationship? So you have between now and 2 o'clock to answer that question.
So please let's answer
Data
after
model.
the class.
Listen, the class will went by 4:45. So you have 15 minutes to answer the question if you don't want to answer right away. But as I'm talking, you still have liberty to call up your WhatsApp chat and submit your own answer within the WhatsApp group. Don't forget that last time I gave you a time limit. And once I've put the time, once you hear time's up, any message after that time up will be disregarded and ignored and assumed to be as if you are joking within the WhatsApp group. So, ladies and gentlemen, you have seen the question, answer where you feel comfortable within the time allowed. Now, let's move down to data modeling. Now,
question again.
Take a snapshot. I will have to move from here. We have limited time. So from there, we move forward. Now, data modeling. In database design, don't forget we are under database design. Now, in database design, there's a step called data modeling. Data modeling is actually the first step. Database design. It's also known as what? Database conceptual design. It's more or less an high-level data abstraction, where we talk about, like, if you want to build if you are interested in constructing a building now, you'll be looking at if I want to build a house now, you'll be looking at number of rooms,
Looking like cheese
number
balls.
of
Like
windows,
I'm using
the
HP.
number of
I have to
doors,
start all this all
the number
over.
of doors that you'll be looking at. At that
Yeah, don't
high
make sense.
level,
Don't
we are
make
looking at
sense. No, my
someone should
secret
just
for
shut up.
I'm
Hello,
still doing
somebody's
it.
disturbing me there. Who is disturbing me now?
So this is my
So at this high level, we are looking at abstraction. That is to say, we are looking at those items that are very important to us. So when you are to design a database, your first point of call is what you have to do a call data modeling or conceptual data modeling, where you look at those important things that are very important to you in the design itself. Now, objectives of data modeling includes capturing the data content in database. What are things that you are to be included in your database? That data, what data are you intend to include in database? That's one. Two, relationship between the data items. Now, if you are cutting your data that those items that you want to be included in the database, maybe you want to include the database of students, database of lecturers, database of database of computers in the lab, or the database of lab, database of equipment in your department. Then you look at the relationship between your labs, your equipment, the students and the lecturers or the instructors. That's the relationship. Under this or this will be considered under a data modeling, which is the first step in your database design. Lastly, you also be looking at the constraints in data. So those are the things that in this constraint to data model in this constraint to what are the limitations of the data? Are you considering only total station equipment? Are you considering only labs that have computers? Are you considering only lecturers in your department or lecturers outside the department? Those are what they call constraints in data. Second step in your database design is basically when you are expressing the data items, relationship, constraints. You're expressing them using concepts provided by high-level data models. Now, when you're using under this second step, you are presenting a conceptual data design or diagram that shows how your data is together. Remember about an ER diagram. In an ER diagram, you are telling us that since you have not your data, you know your data content, you know the relationship among the data content, you know the constraints, then how can you present it in a layman format? So when you are using a diagram called the conceptual diagram or the ER diagram, then that's the second step. The third step, which actually comprises of two steps, database logical design and database physical design. In the logical design, while we were using a textbook on Access database design and programming, Access Microsoft software is an example of a DPMS. And in such an environment, it has its own way of design, it has its own syntax, it has its own functions, it has its own keyboard, key shortcuts, it has its own way of inputting data. Such steps in implementing an access-based database, short steps you'll be taking or you'll be going to call a logical design. Are we together? Are we together?
Yes, sir.
Good. I hope you understood what I mean by a database logical design. I can't hear yes or no.
Yes, sir. Yes, sir.
So when you are trying to actually, first part, we have a conceptual system. Now, conceptual system, we want to now use to tailor it with access. Now, when you are trying to actually tailor our conceptual design into access design, access DPMS, then we are in the third step called logical design. Now, within the third step called physical design, it's called the database physical design. Yeah, we define the internal storage structure, the file organization, and the indexing techniques. Now, if you are to design a database for your school, for a department, you'll be looking at the number, you're looking at the storage capacity that you'll be considering to store data for your school. So when you are in that kind of system, that kind of phase, when you are looking at the physical implementation of your design, of your database design, then we are working within what you call a physical database design. In the physical database design or database physical design, you are looking at the physical implementation or the physical constraints that can affect our internal storage structure, our file organization, our way of indexing, and our actualization of our database. Is that taking?
Yes, sir. Yes,
Good.
sir.
Now, before moving further, I asked you that in your quiz, I asked a quiz that I said, what's the data model? Now, the expected answer for the data model is that the data model is a collection of concepts or notation for describing data or data model or data relationship or data semantics and data constraint. When you are trying to actually describe a data, we use what we call a data model. Imagine you have the coordinate of a particular point, the location of the point, the content of the point, the coordinate system in which the point coordinate has been provided. Now, how do we describe such a data? We use what we call a data model. Now, what is the data model? The data model now encompasses the collections of concepts, notations for describing that data, the data relationships, the data semantics, and data constraints. So within this figure, we define what we call a data model. Now, most data model also includes set of operations for manipulating the data in the database. You can manipulate data model. No, you can manipulate the data. You can add to it, you can subtract from it. And if you specify data model, end user can now actually know what to do with such a data, since they know the data model. Now, as I've said before, imagine you have a topographical sheet that shows your school. Yes, we have faculty of engineering or faculty of environmental science or environmental. Oh, please remind me, which of faculties is your own department located in?
School of Environmental Science.
So, okay, in School of Environmental Science now, you have been asked to actually map out or create a map showing School of Environmental Studies. The first thing you have to do is what they call a database design. Now, in that database design, you do what you call data modeling. Your data modeling, you are now actually looking for those items, those data of your concern. Meaning, you want to say, okay, so I'm not looking for the number of students in this class. I'm not looking for the type of the color of the building. I'm not looking for the purpose of the building. I'm looking for the number of buildings within the geographical area, the structure within the geographical area, and the rest. Are we together? Are we together?
Yes, sir. Yes, sir. Yes, sir.
That is called data abstraction. Under data abstraction, we are looking for
Yes, sir.
just those information that concerns us mainly. Those information that carries high level of priority. If you are asked to describe me, don't want to talk about my color. Don't want to talk about the food I eat. I eat a lot. Don't want to talk about my number of teeth in my mouth. Don't want to talk about the number of wives I've married. Yes or no? Is that important to you? Is that important to you?
It's not important.
Good. So what's important to you is my credentials. Okay, the school I attend. Okay, the number of courses I've taken. So when you are doing also, when you are working with that kind of information, or the purpose of doing that is called data abstraction. So there's a level of there's a degree of data abstraction. Now, under data abstraction, there's some key concepts or key procedures or key techniques or key themes you have to concern yourself with. One of these themes is the external models. Under external models, you are representing the user's view of database. Remember, you are creating data. You are creating a map of School of Environmental Studies. As a result, you want to know what the user, what the end user want to see. As an end user, what do you want to see? Do you want to see the number of buildings? Do you want to see the highest point and lowest point within the building, within the area? Do you want to see the kind of structures or facilities within the geographical area? Do you want to see the kind of grass or vegetation within the area? Do you want to see the natural features and the man-made features? Are we together?
We are with you, sir.
Oh, beautiful. So under external models, you are considering something.
We are not
external.
together. We are not together.
Oh, good. So on this note, for those of us that I said we're not together, I will share this material with you, and I will end the class at this juncture. And ladies and gentlemen, we will be talking about degrees of data abstraction. Under data abstraction, we are looking at prioritization of data concerning database that we are interested in. Is that taken? Hello.
Yes, sir.
So imagine you are supposed to describe yourself. Since you are describing yourself, you are actually making use of those information that you think to the interviewer or to the person that is asking the question. Oh, Mr. Man, describe yourself. You are focusing on those information that will be very important to me, not information that are not relevant at the moment. Though they are also part of you, but they are not important. So that as a result of annihilating some information about yourself and presenting information that are very important to you and to the questionnaire, we are doing what they call data abstraction. Now, under data abstraction, one of those things that is important to us is what we call the external model. The external models relates to the user's view of database, the end user, meaning an external body. How an external body views database. You are looking at the information that is important to that external user or external viewer. Now, the other concept that we are going to be closing upon is the conceptual model. Under the conceptual model, you are providing those concepts, those contents that can describe your data independent of the data DBMS you are using. There are different types of DBMS. There are different types of softwares that manage the database. There are different types of software that manage the database. These softwares are designed to actually take in what you call the logical designs. They are used when it comes to the database logical design. But for the conceptual data design, you are working independent of the software that you are supposed to use or the DBMS that you are implementing. If you are to implement a system in your own school or your department where they will be using a file-based system, the file-based system, which also is also a type of DBMS, database management system, where we are using a cabinet system, where you'll be keeping files based on in the cabinet and we'll be labeling just a cabinet. Are we together?
Yes, sir.
Conceptual models relates to consumption model relates to those the model, the data abstraction, where you are concerned only with the content of the database, the relationship among within the database, and the constraints that will be used within the database. So on this note, I will say thank you for your time. Thank you for your patience. Thank you for your listening here. And if you have questions, please present them at this moment. If you need some clarification, let me hear you out. And in case you need this material, I'll forward it to your group, and material that I'm going to be using tomorrow, forward as well. So thank you, thank you, thank you, thank you.
All right, sir. Thank you, sir.
So once it's 2 o'clock, I'm going to end the class. I'm going to set time up for the quiz. So any question?
Sir, when we go through the material again, we don't have anything that we can about. So we let you know, sir.
I can't hear you.
I said when we go through the material again, after reading, we get it to you, sir, in case we don't understand any aspect.
Okay, that's for you. What about that? No other person, Abi, except you. Okay. Thank you for that. I'll be sharing some materials on your classroom now. So those materials will be used as the class proceeds. So, ladies and gentlemen,